firmware, but it reaches the Windows 11 desktop. The touchscreen works, navigated by tapping and swiping directly on the phone screen. The display driver functions correctly. GPU acceleration operates through Qualcomm's Adreno drivers. Wi-Fi connects on devices where the community has successfully ported the wireless adapter drivers. USB works through the phone's USB-C port. Here's the honest accounting of what actually works and what doesn't, and the community is admirably straightforward about both. The CPU functions at full capability, all cores available, ARM64 applications running natively. The GPU delivers hardware-accelerated graphics, which is why gaming experiments, like the ones from the original community testing, produced playable frame rates. The touchscreen works, though Windows 11 was not designed with a 6-inch phone screen in mind, and using a conventional Windows desktop interface on that screen requires a great deal of precise tapping on controls that assume a mouse cursor's precision. Wi-Fi functions on supported devices with the extracted drivers. Bluetooth works partially. USB connectivity works. Windows Update runs and delivers updates as if this were any other Windows 11 machine, because from Windows Update's perspective, it essentially is. What doesn't work is also clearly documented. The phone's ability to make actual telephone calls is gone. Windows 11 contains no telephony stack, no phone dialer, no SMS client, nothing that communicates with cellular voice networks. The WOA project documentation is explicit. Running Windows on your POCO X3 Pro is not a replacement for a proper phone operating system and does not have emergency calling capabilities. This isn't a driver problem that will be solved by a future update. It's an architectural reality of what Windows 11 is, a desktop operating system that was never designed to interface with cellular modem infrastructure in the way Android was built to do from the beginning. If you install Windows 11 on your phone and try to call someone, you'll find that option doesn't exist in the operating system at all. Audio is variable. Some devices have audio working in some configurations, others don't, and the consistency depends on how much driver work the community has done for that specific hardware. The camera typically doesn't work or works with severely reduced functionality for the same reason cameras are difficult in post-market OS. The image signal processor that handles all of the computational photography work that makes modern phone cameras produce good images requires specialized drivers that exist for Android and don't exist for Windows. Sensors, like the accelerometer, gyroscope, and proximity sensor, are often non-functional. Mobile data, meaning cellular internet rather than voice calls, doesn't work in most configurations. Sleep and wake behavior is inconsistent, which has direct consequences for battery life, because a device that doesn't properly suspend its processor when the screen is off drains the battery at active use rates while sitting idle. Here's what the experience of actually using Windows 11 on this phone looks like. And this is where the experiment goes from technically impressive to genuinely interesting for a specific use case that isn't immediately obvious. Using Windows 11 on a phone's own screen is awkward. The interface wasn't designed for it. And even with the touch screen working correctly, the taskbar, system tray, and application windows that assume a 1920x1080 or larger display are cramped and precise in ways that a 6-inch screen punishes. But connect that phone to a USB-C hub connected to a monitor, a keyboard, and a mouse, and the situation changes completely. The phone becomes a Windows PC, small enough to carry in a pocket, powered by its own battery, running a complete Windows 11 environment on an external display. You can open Word. You can browse the web in Microsoft Edge. You can run applications compiled for ARM64 with native performance. You can connect to corporate networks and run enterprise software that requires a Windows environment. The concept isn't that different from what Samsung has attempted with its DeX desktop mode on Galaxy phones, but where DeX runs an Android interface optimized for large screens, Windows on Phone runs actual Windows with its full application ecosystem and its compatibility with both native ARM64 software and emulated x86 applications through Prism. This is where the Snapdragon 855's relationship to the Snapdragon 8CX becomes most practically interesting. The Snapdragon 8CX was designed specifically for thin, lightweight Windows laptops with long battery life. It's in machines like the Samsung Galaxy Book S, Lenovo Flex 5G, and Microsoft's Surface Pro X. Those machines demonstrate that the chip family can run Windows 11 productively for real work tasks. The phone chip sharing that architectural lineage means that the productivity applications those laptops run are the same ones available on the phone running Windows. The performance gap between the 8CX and the 845 exists, but for office tasks, document editing, and general productivity use, both chips are capable. The community's documentation claims approximately 80% of hardware functionality on well-supported devices, meaning the core compute and display and connectivity functions work, while the phone-specific peripherals like the cellular radio and camera remain unaddressed. The dual boot setup is where this experiment becomes most practically useful for someone who wants to explore Windows on a phone without permanently losing Android's phone functionality. The process carves separate partitions from the phone's internal storage and creates a boot menu through the custom UEFI that lets the user choose between Android and Windows at each startup. In dual boot configuration, you have a full Android phone when you choose Android, and a Windows 11 computer when you choose Windows on the same hardware, with separate storage partitions that don't interfere with each other. The WOA project documentation confirms that Android updates work correctly in this configuration, meaning the Android side of the dual boot continues receiving updates and functions as a legitimate Android device independently of whatever Windows is doing on its partition. The obvious limitation is storage. A 128 gigabyte phone in dual boot configuration might have 60 gigabytes for Android and 60 gigabytes for Windows, which is workable but constraining for both environments. There's a historical thread running through this entire story that's worth following, because this isn't the first time Windows has lived on Snapdragon phone hardware. Microsoft made official Windows phones with Qualcomm chips for years under the Windows Phone brand, and the Nokia Lumia 950 and 950 XL from 2015 have dedicated Windows on ARM porting projects that are still maintained in 2026. The Surface Duo, Microsoft's own folding dual-screen Android phone from 2020, has a WWOA project that enables Windows 11 to run on what was literally a Microsoft-designed phone. The continuity from the Windows Phone era through the Surface Duo to the current community projects running on OnePlus and Xiaomi hardware represents a persistent desire for Windows on mobile hardware that Microsoft officially abandoned, but that a technical community has refused to let die. And in an environment where Microsoft is actively developing Windows on ARM for legitimate products, using the exact same Qualcomm chip generation, the resources the community needs to keep improving these projects, including drivers from Windows Update, UEFI reference implementations from EDK2, and hardware expertise from the ARM laptop ecosystem, continue to accumulate. The honest final question for anyone considering doing this is, should you? And the answer is layered in the same way the answer to any ambitious technical experiment should be. If your goal is to have a functional daily phone, the answer is no. Windows 11 on a phone doesn't make phone calls, has variable audio, unreliable battery behavior, and a camera that either doesn't work or works badly. If your goal is to carry Windows in your pocket for computing tasks in a way that's more experimental than buying a cheap Windows ARM laptop, the answer depends on how much you enjoy the process, because the process of getting here is itself a significant part of the experience, and things will go wrong in ways that require troubleshooting. If your goal is to understand what's technically possible with hardware that manufacturers and software companies have separately abandoned, and to experience firsthand what a community of developers can accomplish without any official support from the chip maker, the device maker, or the operating system vendor, then this is one of the most compelling demonstrations currently available. The Renegade project's UEFI firmware, still receiving commits in March 2026, is an ongoing engineering achievement that started from the observation that a phone chip and a laptop chip shared enough silicon DNA to make something like this theoretically conceivable, and proved through years of work that conceivable and achievable are closer together than most people assume. But the hardware requirements for this version are significant. It requires a 26th generation flagship chip and at least 12 gigabytes of RAM. Read that against the devices people actually have in their hands today. The Pixel 9 series, the Galaxy S25 series, the flagship phones that represent the best of Android as of early 2026. Most of them don't meet the threshold for Nano V3 processing. The Pixel 9 and the Galaxy S25 will run Gemini through the cloud, with the associated latency, permanently, because the on-device acceleration they would need to eliminate that latency isn't available on their hardware. These aren't budget phones. These are the phones that Google and Samsung sold to their most engaged customers last year as the best Android experience available. And after September 4th, those customers will have a demonstrably slower assistant than they had before. Now let's talk about what disappears and doesn't come back, because this is the most practically important part of everything this video covers. The question most people are asking about the transition is whether everything they currently use will work in Gemini. For most everyday use, the answer is yes with caveats. Alarms work, timers work, navigation queries work, quick factual questions work. These are the core commands that the majority of users reach for most often, and Gemini handles them. But for users who built specific workflows around Assistant's unique capabilities, there are specific features that are gone without replacement. Interpreter mode is the starkest example, and the one that will hurt the most people in the most unexpected contexts. Interpreter mode was a feature that allowed Google Assistant to act as a real-time bidirectional interpreter between 26 different languages, spoken naturally in conversation, with the translation handled continuously so that two people speaking different languages could have a fluent conversation. This was used in hotel lobbies, customer service settings, healthcare environments, educational contexts, and multilingual households where it had become a genuinely relied upon daily tool. Interpreter mode was removed from Google Assistant earlier in 2026, and as of August 2026, there is no Gemini equivalent. Not a worse version. Not an in-development version with a launch date. There is currently no Gemini feature that performs real-time bidirectional spoken interpretation across 26 languages. The functionality simply does not exist in the replacement system. Automated daily updates, the feature that allowed users to program a morning briefing combining personalized news, weather, and calendar information into a single daily summary triggered by voice or by time, has no confirmed Gemini equivalent. Family bell announcements and birthday reminder notifications, which were part of the Assistant integrated smart home and calendar ecosystem, were cut without confirmed replacements. Third-party podcast apps, certain radio services, and some music platforms that integrated directly with Assistant's voice layer face compatibility questions under Gemini that hadn't been fully resolved as of the shutdown announcement. The Verge, in its coverage of the September 4th shutdown, specifically noted that Gemini still has missing pieces in those day-to-day features, along with other familiar commands people already use. This is not speculation from critics of the change. It's an acknowledgement in mainstream technology reporting that the replacement system doesn't yet match the system it's replacing in every relevant dimension, enforcing Android developer verification in its first 4 pilot countries: Brazil, Indonesia, Singapore, and Thailand. On August 4th, 2026, Google sent an email to Android users around the world with a single line that ended a 10-year era. Google Assistant on your mobile device is being discontinued. And September 4th is the date they chose. And what's happening on that date isn't a gradual phase-out or background update that most people won't notice. It's the permanent, irreversible removal of a system that has lived in the hearts of Android phones since 2016, replaced by something fundamentally different in ways that most coverage hasn't fully explained. There is no opt-out. There is no rollback. Once your device makes the switch, the assistant you've been using for nearly a decade is gone. Let's build the full picture of what this actually means, because the surface-level story, Google's AI is getting better, Assistant is being replaced by Gemini, everything will be fine, misses several specific things that users with established Android workflows absolutely need to know before September 4th arrives. The change is real, it's technical, and in a handful of specific areas, it removes functionality with no confirmed replacement. So let's start from the beginning, because understanding why this change is happening and understanding what Google Assistant actually was at a technical level is the only way to understand why the transition to Gemini is more complicated than replacing one voice icon with another. Google Assistant launched in 2016. At the time, it was presented as the intelligent layer between Android's search infrastructure and the devices people carried in their pockets. It expanded over the following decade into an ecosystem that few people fully appreciated in its breadth. Phones, tablets, Wear OS watches, headphones, smart speakers, car infotainment systems, televisions, and virtually every smart home device that had a Google logo on it. Hundreds of millions of people built daily routines around its voice commands, from the morning alarm that triggered a news briefing, to the hands-free reminder while cooking, to the live translation conversation that worked across a hotel lobby. What most of those people never consciously thought about was the architecture that made Assistant so fast and so reliable for those specific kinds of tasks. Google Assistant was built on what engineers call a deterministic semantic parsing system. In plain terms, it maintained a fixed library of recognized commands, matched them in constant time, and executed the corresponding action without generating any new language. And when you said, set a timer for 10 minutes, no AI language model was generating a response. The system heard a pattern, matched it to a known command, executed the timer function, and responded instantly. This is why Assistant was so precise and so fast, and why it worked reliably offline for certain command types. The response time was essentially zero from the user's perspective. There was no thinking happening, no generation, no variability. You said the thing, it did the thing. That architecture was optimized for the exact kind of task that tens of millions of people built their Android experience around, because those tasks were fast, predictable, and always worked the same way. Gemini is a completely different kind of system at the architectural level. It's a large language model that generates each word of its response sequentially, producing text through a probabilistic process that considers context and constructs a reply in real time. This is what makes Gemini capable of the conversational, multi-step, reasoning-heavy interactions that make it genuinely more impressive than Assistant on complex tasks. It's also what introduces a latency that simply didn't exist with Assistant's deterministic approach. Security researchers and technical reviewers who tested the transition documented the gap. Gemini adds approximately 380 to 620 milliseconds of cloud latency before it begins acting on a command, compared to Assistant's near-instant response. On the surface, half a second doesn't sound like much. In the context of hands-free voice commands in a car, or quick queries while cooking with hands covered in flour, or alarm setting at 6 in the morning while still half asleep, that gap is felt every single time. Here's the specific hardware detail that turns this latency issue from a minor annoyance into a permanent condition for many users. Google has developed a version of Gemini called Nano, designed for on-device processing, that eliminates the cloud round trip and restores the fast response times users associated with Assistant. On-device Gemini Nano v3 can close this speed gap.